All right, let's talk about something you deal with every single day, even if you don't realize it. We're diving into one of the most fundamental forces in the universe, electric charge. It's happening all around us, all the time, so, let's figure out what makes it tick.
You know exactly what I'm talking about, right? You're walking across a carpet, you reach for a metal doorknob, and zap, you get that little shock. It's a little annoying, sure, but have you ever stopped to wonder what is actually happening in that split second? What's the deal with that tiny jolt of electricity?
Well, to get to the bottom of that little mystery, we have to shrink down. I mean, way down. We're talking about zooming in past the doorknob, past the fibers in the rug, all the way down to the atomic level. Because believe it or not, that's where the real action is. That's where the secret to that spark is hiding.
So what do we find when we get down there? Well, it all boils down to just two fundamental players. And get this, everything from that little doorknob zap to a huge bolt of lightning is basically just a dance between these two types of charge. Okay, let's meet the team. In one corner, you've got your positive charge. These are the protons, and they hang out right in the center of an atom, in the nucleus. And in the other corner, you have the negative charge, which comes from these super tiny electrons that are just constantly zipping around that nucleus. Seriously, every single atom that makes up, well, everything is built from these two. But wait a second, if every atom has these charges, why isn't everything just constantly sparking and zapping all the time? Well, the answer is balance. See, most of the time, objects are electrically neutral. That just means they have the exact same number of positive protons and negative electrons. They perfectly cancel each other out, keeping things nice and stable.
All right, so we've met our players, the protons and the electrons. Now we need to know the rules of the game. How do they actually interact with each other? It's surprisingly simple, really. There are just two basic rules that govern everything they do.
Okay, rule number one is super straightforward. Like charges repel. That's it. If you have two positive charges, they're going to push each other away. Same thing with two negative charges. They just do not want to hang out together. They actively push apart. And rule number two, well, you've definitely heard this one before. Opposites attract. A positive charge and a negative charge will pull toward each other, kind of like magnets. And this isn't just some small thing. This force of attraction is what holds atoms together. It's fundamental to like everything. Okay, so we've got our players, protons and electrons, and we've got the rules. Likes repel, opposites attract. But to really get a handle on this, we need a way to, well, to count it. How in the world do you measure something you can't even see? It's a tough question, but scientists figured out a really clever way to do it. So here's the trick, and it's a really cool concept. Charge is quantized. Now that sounds complicated, but think of it like this. It's like money. You can have a penny or two pennies, but you can't have half a penny, right? Charge is the same deal. It only comes in these tiny individual packets. And the smallest possible packet of charge has a name. It's called the elementary charge. We just use a lowercase e to represent it. And this is the actual value of one single elementary charge. Just look at that number. It is mind-bogglingly small. It's so tiny that it's hard to even wrap your head around it. This is the absolute base unit, the fundamental building block of all electric charge in the entire universe. Okay, so let's circle all the way back to that doorknob zap. What's happening there? Well, that little shock you feel, that's the result of trillions of these tiny elementary charges all jumping at once, either from you to the doorknob or the other way around. It's like a microscopic stampede of charge happening in an instant. Now, obviously, counting in trillions is not very practical, so to make life easier, scientists came up with a bigger unit called the coulomb. We just write it as a capital C. You can think of it like a dozen is for eggs. It's just a way of grouping a massive number of charges together so we can talk about them without using insane numbers. It's way more convenient. So I want to leave you with this final thought. Every single atom in the universe has these forces pulling and pushing, attracting and repelling. So if that's true, what keeps our world from either flying apart or just crushing in on itself? The answer is that perfect, delicate balance. The next time you feel that tiny spark, remember you're witnessing the fundamental forces that build our reality. It's an incredible cosmic ballet happening all around you all the time.